Corporate strategy regarding quantum computing is paralyzed by two extremes. On one side, technological theater driven by hype and branding. On the other, premature dismissal by executives waiting for perfection. Both positions fail because they rely on a shared misconception: the idea that a quantum computer is simply a universally faster version of a standard computer. Your existing IT infrastructure is safe. Standard enterprise software, CRM platforms, and cloud databases will remain entirely classical for the foreseeable future. Quantum computing is a specialized computational architecture. It targets the specific, intractable bottlenecks where classical methods reach their physical limits. Managing the quantum transition requires the rigor of strategic procurement and disciplined corporate governance. To survive this transition, firms must translate the physical realities of quantum hardware into actionable economic materiality for the business. Understanding the economic impact of these machines starts with how they process information. This diagram shows classical determinism. Classical bits, strictly a 0 or a 1, move sequentially through logic gates. Quantum computers use qubits, existing in mathematical combinations of states until measured, allowing the system to handle much richer, probabilistic mathematical structures. Contrary to popular belief, a quantum computer does not simply try every possible answer at the same time. The actual algorithmic power comes from interference. A quantum algorithm manipulates probability amplitudes, reinforcing desirable outcomes through constructive interference, while incorrect outcomes cancel each other out. This algorithmic control over probability creates the advantage. It detaches the value of the hardware from raw clock speed. Quantum advantage centers on achieving computational tractability for problems that overwhelm classical logic. Procuring access to advanced hardware yields zero return if the business problem does not map accurately to the physics of the machine. This map illustrates the first valid problem profile: combinatorial scale. In global logistics, optimizing fleet routing or scheduling supply chains across volatile networks creates a volume of permutations that freezes a classical planner. The second valid profile is physical simulation. Classical systems only approximate molecular behavior. Quantum computers operate on the same physical rules, allowing them to simulate these interactions directly. This provides a measurable advantage for pharmaceutical drug discovery and battery chemistry. The third profile involves problems bound by heavy interacting constraints. In financial services, portfolio optimization requires balancing risk budgets, liquidity limits, and regulatory rules simultaneously. The search for an acceptable allocation under these conditions is an ideal target for quantum methods. But mathematical fit is only half the equation. You must apply the 1% rule. A marginal improvement in solution quality only matters if the problem carries immense economic weight. Applying a quantum method to a trivial, low-value workflow for corporate branding is a waste of capital and executive bandwidth. A problem only justifies quantum exploration if it definitively hits classical limits and directly impacts massive capital allocation. The technological reality of 2026 is that hardware is advancing, but current systems remain noisy and pre-fault tolerant. Enterprises will not be installing cryogenic quantum computers inside their own data centers. This diagram shows the dominant deployment model, the hybrid workflow. Your classical infrastructure retains control, handling data ingestion, security, and validation. The quantum node acts as a coprocessor, executing narrow, complex mathematical kernels, and returning a probability-weighted answer set back to the classical system. This architecture has driven the rise of cloud platform brokers, like AWS Braket and Azure Protum. These platforms provide strategic optionality. Firms can test competing physical substrates, whether superconducting circuits, trapped ions, or neutral atoms, without suffering vendor lock-in. Navigating this ecosystem requires resource estimation software. Resource estimation predicts the exact number of physical and logical qubits, and the runtime required to execute a specific workload. These estimation tools protect your budget. They force teams to prove whether a pilot is actionable on near-term hardware, or if it remains a speculative science project. Smart firms in 2026 focus their capital on cloud-brokered optionality, integration tools, and governance continuity. At the economic layer, traditional enterprise IT metrics fail when applied to quantum projects. Judging an early quantum pilot by immediate ROI, uptime, or transaction throughput will kill initiatives that are strategically necessary. This dashboard shows the required valuation metric for this stage of the market: option value. Option value involves paying a modest cost today to build internal translation talent, preserving your future ability to act and avoiding strategic dependency on external providers. To budget accurately, you must separate explicit costs, like cloud access fees, from the hidden costs of integration burdens and executive distraction. Risk assessment also requires a new vocabulary. Technical risk is the reality of hardware noise. Execution risk involves poor project scoping and weak business ownership. Economic risk is the most deceptive, the danger of successfully solving a problem that fundamentally lacks financial materiality to the firm. Treating quantum expenditure as a staged capability investment, rather than a standard software purchase, is the only way to avoid the ROI paradox. As we project forward toward a fault-tolerant future, the definition of corporate victory becomes clear. The winner will not necessarily be the firm that achieves first-mover status on the newest machine. Competitive advantage belongs to the organization that masters the speed of internal learning, masters cross-functional translation, and relies on disciplined execution. The immediate mandate is to build hybrid data pipelines and educate your cross-functional teams today, long before the hardware reaches maturity. This timeline shows a realistic two-phased strategic roadmap. Disciplined observation, classical benchmarking, and staged unding will always beat blind enthusiasm and massive upfront capital commitments. The ultimate rule of quantum strategy is simple: the business objective must dictate the computation, never the reverse.